Alright, so this is going to be the end of the Chapter 2 review. It has circles and the variation word problems. If you don't get to use a note card on the test, then you're going to have the standard equation memorized for a circle. That's x minus h squared plus y minus k squared equals r squared. Of course, if you turn in your homework on time, you could use a note card. You could write that on your note card. So problems 20 and 21, all they want me to do is shove the numbers that are given into the formula to give the standard equation of the circle. So part of the instructions say write the standard form of the equation of the circle with the given radius and center, and then sketch a graph. Let me sketch a graph first because I don't need the equation to sketch a graph. I'm going to plot the point -3, -1, which is the center. And then I'm going to use the radius to finish up the graph. I'm going to go up 3, left and right 3, and down 3. And then draw something that, kind of looks like a circle. So that's the and sketch a graph part for number 20. And to get the equation that's required, in for the h, I'm going to plug -3. In for the k, I'm going to plug -1. And in for the r, I'm going to plug 3. And I'm going to go x minus -3 squared plus y minus -1 squared equals 3 squared. While this is a correct answer, it's probably not the best answer. I'd say this is an okay answer, but it has double negatives that I don't like, and it has a number being squared that I can get rid of. A better answer to the equation that's needed for number 20 would be x plus 3 squared plus y plus 1 squared equal 9. Both of these would graph into that, something that has a center -3, -1, and a radius of 3. I'll do the same thing for problem 21, meaning I'm going to graph it first and then I'm going to find the equation, because I don't need the equation to graph it if I know the center in the circle. So I'm going to start off by plotting the point -5, +4, which is my center. The radius is 2, so I can go up and down 2, left and right 2, and then draw a circle-ish anyways. Alright, so my equation, so that's part of my answer. Now, the other part of my answer, I have to use the x minus h squared plus y minus k squared equals r squared formula. And in for h, I'm going to plug -5. In for k, I'm going to plug 4. And in for r, I'm going to plug 2. I'm going to write x minus -5 squared plus y minus 4 squared equals to 2 squared. And again, this is an okay answer as to that is exactly the equation of that circle that I drew. But a better answer would be to get rid of that double negative in the first parentheses and get rid of that exponent to the right of the equal sign. So a better answer would be x plus 5 squared plus y minus 4 squared equals 4. Both of them have exactly the same graph, not that that looks like a circle, but something they're supposed to be circles. The next couple problems want me to rewrite the problem so it's written so that I can graph it, so I can know the center and the radius. And for each of these problems, 22 and 23, they ask me to rewrite the problem so it's in standard form. I have to group the x's and the y's, and I have to make the number isolated. So I'm going to kind of do 2 steps in one. In my efforts to get this problem so that I can look at it and know what the center and the radius of the circle are, on the left-hand side, I'm going to put the x terms together and the y terms together, and I'm going to get the number that doesn't have a letter moved to the opposite side. And then, after the x terms, I'm going to add a number that we call C1. After the y terms, I'm going to add a number that I call C2. And I'm going to keep the equation balanced by adding that c1 and c2 to the right-hand side. The c1 is going to be the number in front of the x to the first power term divided by 2 and squared. So my c1 is going to be negative 3 squared, which is 9. And my c2 is going to be the number in front of the y to the first power term divided by 2 and then squared. That's going to be negative 2 squared, which is positive 4. So into my line that I have the red c1s and c2s, I'm going to replace those. I'm going to rewrite x squared minus 6x plus 9 plus y squared minus 4y plus 4 equals negative 9, which is that negative 9. And then in for the c1, I plug in 9. And in for the c2, I plug in 4. I'm going to factor the x terms, or the 3 grouped with the x's, factor the 3 grouped with the y's, and combine the constants. The x squared minus 6x plus 9 factors into x minus 3 times x minus 3. I'm going to bring down this plus sign. The y squared minus 4y plus 4 factors into y minus 2 times y minus 2. And on the right-hand side, the 9's cancel, and I'm left with a 4. So my answer to rewrite this equation in standard form is going to be this. It's going to be x minus 3 squared plus y minus 2 squared. You could write 4, which I would prefer, or you can write 2 squared, because that 4 is equal to 2 squared. Writing it like this, you can tell that the center is the point 3, 2, and the radius is 2. So when I go to get my graph, if I don't have the right side with a square, I have to square root it to get the radius. If I have the right side written with the square, then I know my radius. So for this particular problem, to finish up this and sketch a graph, because there's minuses in the parentheses, I change the sign to get the x and the y coordinate of the center. The center is going to be 3, 2. Because I wrote the number with a square, the radius is a number that's being squared. And my radius is going to be 2. So to sketch this graph, I'm going to just plot the point 3, 2. Go up and down 2, left and right 2, and sketch something that looks, more or less like a circle. And so that would be everything for problem 22. I rewrote the problem in standard form and then sketched a graph. 23 is more or less the same, except I'm going to have to change the signs to get the center because of all these pluses. To start off on 23, the constant's already isolated, so that part of my first step I don't need to worry about doing. I'm going to group the x terms and the y terms on the left-hand side and leave myself some room. So these 2 x terms and those 2 y terms I wrote by each other. After the x terms, I'm going to add a c1. After the y terms, I'm going to add a c2. And I'm going to add that same c1 and c2 to the right side. c1 is the number in front of the x to the first power term divided by 2 and then squared. So that's going to be 1 squared, which is 1. c2 is the number in front of the y to the first power term, first divided by 2 and then squared. 4 divided by 2 is 2, and 2 squared is 4. Now I'm going to replace the c1 and c2 with the appropriate numbers and get x squared plus 2x plus 1 plus y squared plus 4y plus 4 equals 11 plus 1 plus 4. And then I factor, and combine. So x plus 1 times x plus 1. X squared plus 2x plus 1 factors into x plus 1 times x plus 1. I bring down this plus sign. Y squared plus 4y plus 4 factors into y plus 2 times y plus 2. Now on the right-hand side, those numbers add to 16. For an answer to the standard form, I'd write x plus 1 squared plus y plus 2 squared equals 16, or you could write 4 squared. When I go to graph it, because there's plus signs in my parentheses, I have to change the sign to get the center. So for problem 23, the center is going to be the point -1, -2. And because I have the right side written with a square, the radius is that number that's being squared, which is 4. So to do my graph, I'm going to plot the point -1, -2, and go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And draw something that looks like a circle. All right. Next problems, I'm going to have to do some graphing to help myself get started. So 24 and 25 give me the center of a circle, asks me to find the standard form, and I have the h and the k. The equation I'm going to use here is the x minus h squared plus y minus k squared equals to r squared. And in for h, I'm going to plug -2. And for k, I'm going to plug 3. I have to figure out what r is. And I'm going to sketch a graph a little bit of this to get the r. Specifically, I'm going to plot the center, which is the point -2, +3. I'm going to plot the other point on the graph, which is the point 2, 6. And the circle that's being defined here is this circle. That's probably going to go off my page, but that's the circle that's being defined that has the center -2, 3, and it goes through the point 2, 6. The radius is this distance right here. And so to find the radius, I need to find the distance between those 2 points, and the distance between those 2 points I get by taking the distance formula, which is the difference of the x's squared plus the difference of the y squared, and then add them and square root them. So I'm going to find the distance between those 2 points, which is going to be my radius. The distance is going to be x2 minus x1, which I'm going to write as 2 minus -2 squared, and then y2 minus 1, which is going to be plus 6 minus 3 squared. This is going to give me the distance between the 2 points, which is the radius, is going to be 2 minus -2, which is 4, because the double negative goes positive, squared, plus 6 minus 3 squared is going to be plus 3 squared. So the distance is going to be the square root of 16 plus 9. The distance between the 2 points is the square root of 25, which is 5. And so the radius, the r in this problem, is 5. And that's what I'm going to plug into the formula for my r. Now I'm going to just take those numbers, plug them into the formula, and I'll get an answer, and I'll clean it up by simplifying a little bit. So an okay answer to problem 24 would be writing x minus -2 quantity squared plus y minus 3 squared equals 5 squared. And of course, a better answer to problem 24 would be x plus 2 squared, getting rid of that double negative, plus y minus 3 squared equals 25, getting rid of that square on the right-hand side. But I would take either. The top one maybe is easier to graph because you can see the radius nicer, but the bottom one is probably the one that I would write for my answer. All right, one more circle problem, and then we get into word problems. And the circle problem, this one's the hardest one because it doesn't give me the center, nor does it give me the radius. And I have to graph this to get started. So I'm going to graph this circle, and I'm going to graph the endpoints of a diameter. So I'm going to graph the point 1, 4, and -3, 2. So these points are a diameter, which means If I connect those 2 points together, that smack dab in the middle of those 2 points is going to be the center of my circle. The center that I need for this is the midpoint of the diameter, and a midpoint is found by the midpoint formula. The midpoint formula, the x part of the midpoint, you add the x coordinates of the points and divide by 2, and the y coordinate of the midpoint, you add the y coordinates, divide by 2. So for this particular circle, its x coordinate of its center is going to be the x coordinates, -3 plus 1 divided by 2. The y coordinate of its center is going to be 2 plus 4 divided by 2. This is going to give me -2 over 2 and 6 over 2. So the center, which is the midpoint of that line segment, is going to be the point -1, +3. That almost looks reasonable for my graph. So I've got that done. So I have the center, -1, 3. So my h is going to be -1. My k is going to be 3. I also have to find the radius. And the radius is the distance from the center to any of the points along the edge. I'm going to find that distance right there and call that the radius. To find that distance right there, I'm going to use the distance formula. And I'm going to take the difference of the x coordinates, 1 minus -1 squared, and the difference of the y coordinates, 4 minus 3 squared, add them and put them under a square root, and that will give me the radius. So 1 minus a -1, I have a double negative there. That's going to turn to a 1 plus 1, which is going to be 2 squared. And this 4 minus 3 is going to be 1 squared. This is going to give me the distance, or the radius, is going to be the square root of 4 plus 1, which is the square root of 5. So the radius that I highlighted there is the square root of 5 units. So now that I have my information, the center and the radius, I can give you an answer to this, the equation of this circle, by going x minus h squared plus y minus k squared equals r squared. So this would be an okay answer, because it fits perfectly. It has a center of -1, 3 and a radius of the square root of 5. I would probably write a better answer by getting the double negative inside the x parentheses turned into a positive. So writing x plus 1 squared plus y minus 3 squared on the right-hand side, left-hand side, and on the right-hand side, the square root of 5 squared is just 5. All right, so we just have word problems to do. That's the varies inversely, varies directly, and varies jointly. And we'll just kind of jump right into those, and just, we only have 1, 2, 3, 4 whole problems for the review, which should be another 10 minutes or so. So the last few problems on this review are dealing with the variation problems, and it's going to be important to remember the keywords and how they translate into equations. When I do these variation problems, when I see inversely, I think fraction with k in the numerator, and usually the algebra involves cross-multiplying. If I see jointly or directly, I think multiply. Jointly, like I see in 27, I think multiply, and I say 2 letters after the k. And not on this page, but in a bit here we'll see directly. when I see directly, I also think multiply. The difference is there's going to be one letter after the K. Don't have room to write after the K so well. So when we do these groups of problems, that's the first thing I need to concern myself with. If it's a varies inversely, it varies directly, or varies jointly. And each of the problems on the review are the 3-step problems, so we won't have to worry about the 1 or the 2-step problems. And for the 3-step problems, first we create an equation with a K, then we use the numbers in the second sentence to get a value for K, and then ultimately we get an answer. So step 1 is for each of the problems that we're going to do to finish up the review, we create an equation with a K. And then step 2, I'll use the first group of numbers to solve for K. And none of the first 2 parts need to show up in my answer. And then step 3 will answer the question that's posed in the last sentence, but it's not really even with a question mark, but it is supposed to be the question. So I'll use the number or the info in the last sentence to get my answer. And I don't have to show any of the answers from step 1 or step 2 in my final answer. I guess you could, but it's not necessary. So another thing that I have to worry about is if I start to see words with the word root following them or not following them. And all we saw was square, square root, cube, and cube root or cubed root. I'll make all of these x. A square means an exponent of 2. A cube means an exponent of 3. A square root, you get a square root symbol with a letter under the square root symbol. A cube root, you get a cube root symbol with the number under the cube root symbol. All right, so this blip on the top and this blip on the bottom, along with these steps, that's everything that we needed to accomplish the before we could solve the problems. So 26, I see M written first, so I'm going to write the letter M and getting my equation with a K, followed by an equal sign. If I see the word inversely, I immediately make a fraction with a K in the numerator. And then after the K, I need something to represent the square root of N. I'm going to write a square root symbol, and the N's going to be under that square root symbol. Done with the first sentence, moving on to the second. The second sentence is going to give me enough information so I can solve for K. The second sentence says M is 3 when N is 16. So into this equation, I'm going to plug in M for 3 and 16 for N. That's going to give me 3 equals K over the square root of 16. We usually solve these by cross multiplying. To make it something I could cross multiply, I'm going to make this 3 over 1. And then the K over the square root of 16, I'm going to make K over 4. And then I'm going to cross multiply up and cross multiply down. When I cross multiply up, I get 1 times K, which is just K. When I cross multiply down, I get 3 times 4, which is 12. So this was my step 1. This is my step 2. I haven't got to the last sentence, so I don't have an answer. I'm going to move on and do my step 3. I've put it on another sheet of paper just because it'll fit better. Step 3, I'm going to use the info in the last sentence. Find M. So I'm going to leave M in my equation and M because I'm trying to find it. When N is 25, so into my formula, I'm going to plug 25 for N, and I'm going to plug 12 in for K. The answer that I'm going to get for question 26 is step 3 of question 26. The answer, I don't need to do any extra algebra in terms of cross multiplying because the letter I'm trying to solve for is already solved for. It's going to be 12 over 5. It's going to be m equals 12 over 5 because I'm trying to solve for m. All right, so that's all problem 26. This is the answer to problem 26. First, I looked at the first sentence, saw inversely, made an equation with a fraction with a k in the numerator, used the numbers in the second sentence to get a value for k, moved down to the third sentence and got my answer. For problem 27, I'm going to use the information in the first sentence to create an equation with a k, and the first letter I see is the letter y, so I'm going to write the letter y followed by an equal sign. I don't see the word inversely, so I don't need a fraction. I see the word jointly. I'm going to have a k, and it's going to be followed by 2 letters as opposed to 1. The 2 letters are going to be x and y, x and z. If I look right before the letter x, I don't see any of these keywords, so the x isn't going to have an exponent, nor is it going to be under a radical. If I look at those z, the words immediately preceding the z are the square of z, so the z is going to get an exponent of 2. Done with the first sentence, move on to the second sentence. The second sentence gives me numbers to plug into the equation and enough numbers that I can solve for k. So I'm going to plug 128 in for y. I'm going to leave the k alone. I'm going to plug in 2 for x and 4 for z. And then I'm just going to solve this. I'll solve it this way to save some room. This is going to give me 128 equals, and then this is 2 times 16, so it's going to equal 32k. And then I'll divide both sides by 32. 128 divided by 32 is 4. And on the right-hand side, I have my k. So there's my first step, my second step. I'm going to sneak my last step in here. My last step wants me to use the information in the third sentence. Find y when x is 3 and z is 5. I'm finding y, so I'm going to leave y alone in this equation. In for k in this equation, I'm going to plug 4. In for x into that equation, I'm going to plug 3. And for z in that equation, I'm going to plug 5. Orders of operations force me to do the exponent first. So this is going to be 4 times 3 times 25. And my answer, I think this comes out to be 300. I should probably have my calculator out. And it should probably be y equal to 300 because I'm solving for y. Alright, so just a few more problems to do. Specifically, just 2 more problems to do. And they're the longer word problems. But the longer word problems aren't noticeably different. They're the same 3 steps. I'm going to create an equation with a k, use the first group of numbers to solve for k, and use the information in the last sentence to get my answer. So for 28, I'm going to dig through the first sentence. And in this first sentence, I see the letters that I need. I need a D and P. And I see that key word inversely. So when I create my equation, it's going to have a fraction with a k in the numerator. So as I read through this, step 1 is to create an equation with a k. Suppose the demand D, right, D and then equals, for candy at a movie theater is inversely fraction with a k in the numerator related to the price P. So the first letter I see is D. The first letter that I see always goes to the left of the equal sign. After the equal sign, the first thing I always write is a k. If I don't see the word inversely, I don't need a fraction. If I see the word inversely like I need here, I get a fraction. And then the next letter I'm going to write is a P. The P stands for the price of candy. And I don't see any words after inversely before P that say square, square root, cube, or cube root. So I'm just going to leave the P all by itself. Done with step 1, I'm going to move on to step 2. Step 2 says when the price of candy is $2.50 per bag, the theater sells 150 bags of candy. I need to take those two numbers, plug them into the right letters in the formula to solve for k. Specifically, I'm going to put $2.50 in for the price and $150 in for the number of bags of candy. So we get 150 equals k over 2.50. I like to solve these by cross multiplying. In order to solve these by cross multiplying, I need both sides to be a fraction. The side that wasn't a fraction, I can make it a fraction by putting it over 1. And then I can cross multiply down, and I can cross multiply up. Again, to save some room, I'm going to write it over this way. When I cross multiply up, I get 1 times k. When I cross multiply down, I get 150 times 2.50. And don't care to do that, so 150 times 2.5, I get 375 for k. Almost done. Now I move on to the last sentence. And I need to use the last sentence. This last sentence only has one number in it, and it has one question. So it says determine the number of bags of candy. The number of bags of candy is the D. So it says determine what D is if the price is raised to $4 per bag. So what I'm going to do is I'm going to take the number in the last sentence, put 4 in for the price, and plug 375 in for the K. That's going to give me how many bags of candy are being demanded, and apparently it might come out to a decimal, and you can't sell like 1.5 bags of candy at a theater, so I'm going to round it because my hint says to round. So I'm going to leave the D in this equation D. I'm going to plug 375 in for that K, and I'm going to plug in $4 for this P. I don't really need the 2 decimals, but it's okay to have them. When I do 375 divided by 4, I get 93.75, and you can't sell that quantity of bags of candy, so I'm going to round like it says to, and the nearest number I'm going to round to 94. So my answer, I can say we're going to sell about 94 bags of candy. All right, one last problem for this monstrously long review. Problem 29 is another longish word problem. It has 3 steps. The first step, I'm going to come up with an equation with a K, and in this sentence, I see the word directly, and when I see the word directly, that equation is going to be a multiply and no fractions, and 1 letter after the K. So the first sentence talks about a ball rolling down the distance a ball rolls down an inclined plane, and it's directly proportional to the square of the time that it rolls. Ugh. Well, the first letter I see is D. It stands for the distance that the ball rolls. I'm going to write my D first, followed by an equal sign, and then a K. I don't see inversely, so I don't get a fraction. After the word directly, and preceding the letter that stands for time, I see the square of the time. That tells me the time needs an exponent of 2. Done with the first sentence, move on to the second sentence. Second sentence says, in 1 second the ball rolls 10 feet. So I'm going to put 10 in for the distance and 1 in for the time. This will give me 10 equals just k, because this is k times 1, which is just k. So first sentence gave me an equation with a k. Second sentence, I took the 2 numbers in, solved for k. Move on to the third sentence. The third sentence, how far will the ball roll in 5 seconds? I'm going to use this equation, and I'm going to plug in 10 for k, and I'm going to plug in 5 for t. I'm going to get D equals 10 times 25, and 10 times 25 is 250. And I should probably get units. This is the distance that the ball is rolling, and my ball is rolling in feet. So my answer for 29, I can say the ball will roll 250 feet. And that's everything on the review. If you can do all 29 of these problems, you should be perfectly prepared for the test. There'll never ever be anything on a test that isn't just like a problem on the review.